Hi everyone, myself Dr. Nehru Boda, working as Assistant Professor in Physics, Department of Freshman Engineering, Saint Martin Engineering College. So now this session I am going to explain auto combustion method or combustion method. So this method is belongs to nanotechnology. So what we have introductions. First one is introduction of the nanotechnology. What is nanoscience and what is nano? What is a nanometer? What is a nanoscale? So that is the introduction of our topic. Next one, preparation method. So we have preparation techniques. So we have different techniques are there. So how to prepare our sample? How to prepare our sample at nano level? So that is a preparation level of the our sample. So this is preparation of our topic. So and next one, so flow chart. So what is the flow chart? Flow chart means how to prepare our materials at nano levels. We have different stages of our material. So we are going to start into end position of the synthesis. We follow a procedure that is called as flow chart of the synthesis. So next one, calculation. So calculate our samples. We are going to start synthesis. Before we are calculate our samples and we choose the formula of our samples. So that is the case of calculations. Next, calcination of our sample. So after getting our sample synthesized powder, calcination means that is a heating process. How to heat, at how much temperature degrees centigrade. So by using the muffled furnace, we heat our sample. That is the calcination process. Next, advantage of this method. Where you choose this method? So this method is very easy and effective method to prepare our sample. That is the advantages. Next, precautions. Precautions means during the synthesis we are follow some techniques. We are follow precautions. These are mandatory. So that's why we are also learning about the precautions. And this method gives some applications. We have some applications by using this method. So this is a next one. So what is introduction of the nanotechnology? Okay, already we know what is nano. Nano means 10 to the power of minus 9. Nano means 10 to the power of minus 9. So that is the nano. 10 to the power of minus. What is the nanoscale? 1 to 100 nanometers. 1 to 100 nanometers. So what is our aim? Aim of the method to prepare our sample. To prepare our sample at nano level. So that's why. So this is nano. Nano is equal to 10 to the power of minus 9. Nano is equal to 10 to the power of minus 9. What is nanometer? Suppose 1 nanometer is equal to 1 nanometer is equal to 10 to the power of minus 9 meter. Okay, this is the we are aim of the synthesis. So what is this? What is nanotechnology and what is the nanoscience? Suppose nanoscience. Nanoscience means it is a branch of science. It is a branch of science. Nanoscience means branch of science. So we are going to manipulate, this is a phenomena, we are going to manipulate our sample at atomic or molecular. Atomic comma molecular. So molecular levels we have to prepare our samples. So that is called as the nanoscience. It is a branch of the science to manipulate our sample at nano level. What is nanoscale? Nanoscale means, so nanoscale is equal to 1 to 100 nanometer. So this is our range. We have to prepare our sample. So that is the nanoscale. Next one is nanotechnology. What is the nanotechnology? Nanotechnology means, so it is a technology. It is a technology to implement our samples at which status, which areas. Nanotechnology means it is a branch of engineering physics. It is a branch of engineering physics. So we are using this nanotechnology to prepare our sample. We have take any materials, any raw materials or any object to convert to nano level. So that is called as the nanotechnology. So design. So it is design our samples. So what is the design? Design means we will design a sample at nano level, nano rods, nano tubes. So that is called as a design. So next one is characterization. We are also apply the nanotechnology in characterization techniques. Well, we have different techniques of the characterization techniques. First one is XRD. First technique is XRD. XRD means X-ray diffractometer. Next one is SEM. SEM stands for scanning electron microscope. SEM stands for scanning electron microscopy. This is the one of the characterization technique. Next one is a TEM. TEM stands for transmission electron microscope. What is the transmission microscope? It will give a very accurate particle size of the our material. Okay, that is in the range of 1 to 100 nanometer. Okay, more than 100 nanometer. Those are not our nanoparticles. So 1 to 100 nanometer means our particle is belongs to nanomaterial. So these are the nanotechnology. So next what? So what is the nano? So now we are study nanotechnology, nanoscience and nanophysics. So let us take a sample. So let us take any bulk materials. Let us take any bulk materials. We have to. So this is a bulk material. This is a bulk material. So this is bulk material. Why are you choose this bulk material? To convert this material into nanoparticles. So we are measuring this bulk material by using millimeters, centimeters or micrometer if it is possible. But we cannot measure our nanoparticles by millimeters, by centimeters. So that's why we will reduce the size. So next one is what is next? So this is the powder sample. This is the powder sample of the second stage of our material. So this is the first stage, that is the raw material or bulk material of the sample. So this is the second stage. Second stage means that is the powder stage. What is this? Powder stage. Powder stage of our sample. Powder sample. How it is getting our powder sample? During we are taking any synthesis process. We convert our sample to powder stages. What is the next stage? The next stage is nanoparticles. Next stage is the nanoparticle stage. So these are called as the nanoparticles. So how to measure nanoparticles? Nanoparticles are measured with the nanoscale. Suppose our sample belongs to nanoparticles. How it is confirmed? Our particle nature, our scale is 1 to 100 nanometers. That's why we are judge our sample belongs to nanoparticle range. So this we are observing here. What happened? So that is the top position bulk material. Next stage is powder sample. What is the next stage? The final stage we are getting the nanoparticle. So this is our ambition. That is our aim of the synthesis. So what is next? So how to prepare our materials? Introduction completed. Next what? How to prepare our materials? So that is our material is preparation is the main technique. We are choose already auto combustion technique. Preparation. The fabrication of nanomaterials have two main techniques. Those are, first technique is top down approach. First one is top down approach. Top down approach means this is a technique to prepare our material in the nano range. So this is a top down technique. What is the top down? First we will learn definition part. Top down means our material is bulk material. Suppose our material is bulk material. So see here, what is this bulk material? Top down means bulk material means the top position, or this is a big size material. So what our ambition? To convert our material into nanoparticles. So this is the first stage of material. So next one is the powder stages. So next one is powder. Next one is the nanoparticles. So this is, we are see here first stage. This is the second stage. This is the third stage of our materials. This is the third stage. So what it is? Top to down. We are comparing here. This is the raw material, bulk material, top position. This is the second position of it is we are measuring this powder sample. If it is possible through micrometer. But this is not possible. Why? These are nanoparticles. So that's why alternately we had choose nowadays generation. These are technologies well developed in all areas, only in science. Okay, that is nano. That is the top-down technique. This is the top-down techniques. So it has in the top-down technique. It has main two techniques. Two methods are there. What is that method? First method is ball milling. First method is ball milling method. So this method is not a chemical route technique. This method is not a chemical route technique. The second one is PVD. So see here, what is these techniques? What is this method? These two methods are belongs to top-down approach. Top-down approach. So these two techniques are not a chemical route technique. These two techniques are the chemical route technique. So that's why we are applying any mechanical stress on that material. See here. So this is a Vishal. This is a Vishal. What is that? We have to. This is our rotation of the Vishal. We are insert iron or steel balls. Iron or steel balls insert in this Vishal or drum. So this is the different stages of the. So these are three balls. Or how much volume we are insert the balls? 30 to 40% of the complete volume we are insert the iron or steel balls, and also we are insert the our material. Also insert the our material. So this is called as the raw material. So next method is called top-down approach completed. Next one is bottom-up approach. Next one is B, bottom-up approach. Bottom-up technique is also a bottom-up approach means this is also a preparation technique. So this technique is also prepare nanomaterials. So we are using the nanomaterials. So top-down technique is not possible for chemical route technique, but these bottom-up techniques are the chemical route techniques. Bottom-up techniques are the first one is what is this? This method has sol gel method. This is first one is sol gel method. So next method is precipitation. Next method is precipitation technique or precipitation method. Third one is CVD. CVD stands for CVD method. CVD stands for what is CVD? Chemical vapor deposition. So this is one of the chemical route technique. Okay. So next technique is last technique. That technique we have to choose. Why? Because so that is a combustion techniques. So our technique is called combustion technique. So that is our aim. Combustion method is our aim to prepare our nanomaterials. To prepare our nanomaterials at fine powder we are getting. So that's why we choose nanomaterial. This method, combustion method. What is the combustion? Combustion means it is a process of combustion means it is a process. It is a heat generation, heat and light in the form of fire. So that is the combustion method. Very easy, and we save the time of this method by using this method. We have to. So next one is combustion method. What is the aim of the combustion method? Why are you choose this method? So this method is belongs to nanotechnology material. So what is nanotechnology? Nano already we discussed nanotechnology, nanoscience, nano powders, and everything we have to discussion. So now we are going to plan the accordingly. So this is our introduction. So what is already nanoscience we discussed? Nanoscience means it is a branch of science. It is a branch of science. Nanoscience means it is a branch of society. Nanoscience, it is a material. We will take any material, any sample to our range. So what is this? So this is the nanoscience, and this is the nanotechnology. Okay. Next one, what is we choose our method? What method we have chosen? Chosen our method. So that is the properties of our method is belongs to nanoscience and nanotechnology. Different methods we have. First method is sol gel method. Second one is acetyl gel method. Next one is Next one is soldier, soldier precautions, and everything we have to study by using this method. So that's why this method is belongs to nanoscience. So next one is aim of the method. What is our aim? What is our aim of the method? Where you choose this method? So this method is, what is the principle? The combustion method principle is, so what is the principle of this method? When a substance react with oxygen, when a substance react with oxygen, the forming a light and heat in the form of fire, That is the principle of the auto combustion technique. So next one, what is the definition of the combustion? So already we are discussing combustion, but what is the definition of the combustion? It is a high temperature exothermic, So what is the meaning of exothermic? Release the heat, okay, that is exothermic, and a chemical reaction between fuel and oxidant, okay. So this is the process of the combustion. So what is our aim? To prepare nanoferrites. This is our formula. So we are going to start prepare one sample. What is the example? Cadmium X, cobalt 1 minus X, Fe2O4. So this is our structure of the cubic structure. So what is the structure is M, Fe2O4, and also you can write as A, B, Fe2O4. So this is the structure. What is A? Here what is A? What is B? A stands for divalent materials. A stands for, we are choose divalent materials. For example, cadmium. Next one is B stands for tetrahedral materials or nanoscience. Nanoscience and nanotechnology we will discuss well. So next, preparation techniques. What is our preparation technique? We have different techniques are there. So those are top-down approach and bottom-up approaches. We have different techniques. But what next? It is we have study. It is so top-down approach. Top-down approach means, so this method, this is a ball milling. Top-down approach. First method is ball milling. Second one is PVD. So in case of bottom-up approach, we have 4 main methods are there. Those are first sol gel. Next one is precipitation method. Next method is CVD, and we are choose the combustion method. Why? So the combustion method is there is a principle of the combustion method. Okay. So what is the combustion? I'll discuss. So prepare nanomaterials to prepare nanoferrites, and XRD. XRD gives the well data. Our material is belongs to our crystalline nature or amorphous nature. Our material belongs to crystalline or amorphous. It will give the result of XRD. Next one is SEM. SEM stands for scanning electron microscope. It gives some surface morphology of our material. What's next one? EDS. What is EDS? Energy dispersive spectra. This spectra gives atomic percentage and moleculars in our powder. How many materials are there? Cadmium is there or not? It will give the accurate value. So next one is electrical properties and magnetic properties. It is by using this method, our material is applicable for electrical property and magnetic property. So that is number one method. So that's why I am choose. Next one is advantage of this method. So it has different advantage. So we have to, this method is capable of yielding homogeneous mixture. That is we want. Homogeneous means our material is good. So homogeneity, there is no contamination. That's why our material belongs to homogeneous. So this method gives a homogeneous powder. Next one, what is the, so we also save saving time and energy by using this method. So that's why we are choosing this method do for synthesis. Next, these are operators. Okay, we are going to start synthesis. We have different operators are required. What are they? So next, first one, sensitive balance. What is the sensitive balance? It will measure our sample accordingly weighing. Next one is glass beakers. these two beakers we required during the synthesis. So that's why 100 ml beaker and 500 ml beakers we are choose. Okay. Next one, magnetic stirrer. What is the magnetic stirrer? So this is our main part of the synthesis. Our synthesis main instrument, main experiment. What is this? Magnetic stirrer. It have two properties. One is stirring purpose. Another one is heating purpose. Okay. Next one, pH paper. It will decide our sample is belongs to acid or basis or neutral. But we want neutral. How much? pH is equal to 7. We want pH is equal to 7. That is our. Then we are getting powder is they have a fine powder or homogeneous powder. That is pH paper. Agate motor. This is used for grinding our sample. Next one is muffle furnace. This is calcinate our sample. Okay, lost any water molecule from the powder. How it is possible? We are using the muffle furnace. Next one is these three are the cotton, acetone, nitric acid and spatula. These are the cleaning of the our crucibles or beakers, everything. So these are often required during the synthesis process. Next one is this material we have to choose. Which purpose? Our sample is cadmium X, cobalt 1 minus X, Fe2O4. That's why ferric nitrate, citric acid, ammonia solution. These are required materials during the synthesis. So next one. So this is the main concept of the. This is the main concept of the our sample. What is this? Stoichiometric calculation. That means we are going to start synthesis. We will do calculation. Okay. So this is our sample formula. What is the formula? Cadmium X, cobalt 1 minus X, Fe2O4. We are substitute X is equal to 0 value in this formula. What is where you choose X 0.1? That is the mole percentage. So then we are substitute the X value. We are getting cadmium. We are getting the cadmium 0.1, cobalt 0.9, Fe2O4. So then we are required the cadmium formula. So that is the atomic weight of the cadmium. It is the atomic number. It is the molecular weight of the cadmium. Similarly, the cobalt. It is a ferrous. It is the oxygen. It is the main part. What is our main part? Here, atomic weight. Atomic weight of the sample is required. What that? So atomic weight. How to calculate? Total atomic weight of a sample. 0.1. It is the mole percentage of the cadmium into it is the atomic molecular weight where we are collecting the molecular weight from the sample bottle. So that's why I multiply 0.9. This is the concentration of cobalt into molecular weight of the cobalt. Next 2 into iron, 4 into oxygen. In case finally we are getting the total atomic weight of the sample. So now what? Individual atoms, individual molecules we calculate. How it is possible? So we have one formula. So cadmium nitrate that is equal to 0.1 cadmium concentration into 308.47. What it is? Molecular weight. It will collect from the bottle into 10. Where you multiply with 10? It final stage our sample we want 10 gram powder. That's why we are multiplying with 10 or 20. So that is by total atomic weight of the sample. Then we are getting how much value for cobalt nitrate? 1.289. 1.289. That is a cadmium nitrate. Similarly, what is a cobalt nitrate? 10.91 gram. Ferric nitrate 33.9 gram. So these are our stoichiometric formula. So next this is the weighing machine to calculate weighing our samples. This figure shows, for example, cobalt raw material, iron raw material. Next one is this is the main part of our experimental setup. This is the magnetic stirrer with a hard plate. This is the 500 ml beaker. So this is the hard plate. This is the beaker. This is the stirrer. It has two properties, heating and stirring properties. So next one, this is the flow chart. This is the main part of our synthesis. What is this? So let us take a beaker. Let us take a 500 ml beaker. So we insert cadmium nitrate, we insert cobalt nitrate and iron nitrate and next citric acid. So these are our materials. So every material, which materials? We are adding all nitrates, we are adding all nitrates and citric acid plus distilled water. So this is the main distilled water. We fill this all three things in this beaker. How much millimeters? Suppose 300 ml. 300 ml we have to fill this. So what next? So keep on the magnetic stirrer. This beaker is keep on the magnetic stirrer. We are start stirring of the magnetic stirrer and we are adding ammonia solution. We are adding the ammonia solution drop by drop and maintain the pH 7 and maintain the pH 7. Okay. When we are getting the pH 7 by the pH paper, our solution is homogeneity. Our solution is called homogeneity. Next what? We are remove the pH paper and we are remove the magnetic bead. What next? Heating process. First, how much heating? First, how much process we are heating? 80 degrees centigrades. 80 degrees centigrades. So, viscous gel. Our product is from viscous gel. Next, we are increase the heating process. Our solution goes to dry gel. So, then our powder is coming up to 100 ml. Okay, we are increase the heating capacity of the stirrer. So, that's why how much degree centigrade? Till 200 degrees centigrade. The process will take up the combustion reaction. The process will take up the combustion reaction process. So, these are different stages of our sample. Different stages. What stages? First one is viscous gel. Second one is self-ignition. These all they based on the heating. Suppose here 80% we are heating 80 degrees centigrade. Here 100 degrees centigrade. What is here combustion process? Till 200 degrees centigrade. Till 200. So then we are getting the auto combustion form in the form of heating and light. Heat and light in the form of the duration. So next one, see the agate motor. This is the agate motor. Which purpose we are grinding our sample. So this is our sample bottles and crucibles. Okay, collect our samples. So next one, so this is the muffle furnace. This is the muffle furnace for calcination of our sample. So next one is the precautions. We have different precaution. Wear masks, gloves, glasses and aprons and shoes. Okay, these are mandatory during the synthesis. These are applications. This method is very good application. And to this we are prepare the sample, advanced materials, powders, ceramics, composites and also prepared some materials in the functional materials also prepared by using this method. So that's why I am choose this method. I am explaining about this combustion method. So because next one is these are characterization techniques. These are characterization technique. What is this? Different characterization techniques. After powder, we are getting the characterization technique means physical techniques, XRD, FTIR, SEM, EDAX and TEM. These three are the characterization techniques. So already we get the powder na. So how to calculate, how to decide. So this is a magnetization. Magnetization means our material is belongs to soft or hard magnetic materials. So it will decide the magnetization property. We have to. Next one is DC property. What is DC? DC means it is a storage device, electrical storage devices, where our material is good material and also provide this type of facilities and this type of characterization we will do. These are XRD figures. XRD shows so our material is belongs to XRD pattern. How it is possible? Our material is crystalline nature or amorphous nature. We are getting the sharp peak. Our material is called crystalline nature. Our material is crystalline nature. Okay. Suppose there is no sharp peak. We are getting number of peaks, but those are not sharp. That means amorphous nature. But our material is crystalline nature. Okay. So next one, what is next? So we are also calculate the crystalline size. Our material is belongs to crystal nature. So that's why we find crystalline size formula. D is equal to 0.91 lambda into beta cos theta. So these are amorphous, these are EDS spectra, and this is a temp figure, surface morphology. So next one is our this is our supporting video for our materials. So this is the combustion process method. So this video shows our sample. It is good. Why? Because we have already complete the time. So already we getting our sample is in the form of what is this? So already we studied. We already prepared materials. So stop the stirring. Stop the stirring. We start the heating. Start the heating process. Starting heating process, and our material is, so it is the combustion process. Next we will see here. So this is the stage heat and fire. This belongs to heat and fire in the form of fire. Heat. See here, light and heat. That is the combustion technique process. This is very easy technique to prepare our material to homogeneity and good materials. We study well about this material. So this is our combustion technique. So that's why I am choosing this method. So this video shows it is a burning ash powder. What is this stages? Burning ash powder. And so this light. See here, what is the light here? Light and heat generated. Our powder is, our solution is completely heating, completely burning our powder. Okay, that is the combustion process. Yes, this video is very good to support our synthesis method, our combustion method. So that's why we are getting the combustion. So this is the process of this is the process of our materials. So this is our topic. It is the nanotechnology, nanoscience, combustion method. So we are well discussed about this method. Very good again. So thank you all.